Right, we're following on from a previous video on Spearman's rank correlation coefficient, and in that one I explained what the idea was behind it, and now we're going to actually look at two tests. I call them test X and Y this particular time, and so we're going to look at how correlated the test scores for the students are between one test and another. We're going to use Spearman's rank correlation coefficient. So the first thing we're going to need to do is rank the test scores. Now, just before I do it for the actual data, I just want to talk about what happens if you get tied ranks. So for example, if these are our test scores, it's fairly easy to see that this is ranked first. Now, what you might do is say, well, this one is second and third, and this is fourth, fifth, and sixth. But actually, in Spearman's, what you do is that would be for ranked first. These two, you would take the average of the ranks for where they've got the same score. So actually, they both become 2.5. Average of 2 and 3. This particular one, these three have all got scores of 17, which ties them on the same rank of 5, because 4 plus 5 plus 6 divided by 3, you'd end up with 5. So these are the ranks we're going to use, not these ones. So therefore, if we move over, you'll see that we're going to end up with, that's ranked first, then we've got our second and third, so both 2.5. So that's our second and our third. We're now looking for our fourth and our fifth, which are both 12. And as the fourth and fifth, we're going to have to average out fourth and fifth rank as 4.5. Now we're on to our sixth and seventh, which again, 2 8s. So we've got our sixth and seventh averaged out to 6.5. And then we've got eighth and ninth. So that means you should notice now that n is 9. Doing the same thing for the other test, and the highest score was 17. So they're both going to be tied for first, and we'll take the first and second and average it out there. Moving on, we've got two 16s, which are tied for third and fourth. So we rank them 3.5. Then what have we got next? We've got 13. So we've done first, second, third, and fourth. And our first 4, so that would be fifth, then sixth, then seventh, then eighth, then ninth. Now, what we need to do now is work out the difference between the ranks. Obviously, if the ranks have no difference between them, then we're going to get a very high level of correlation. What we always do is you do the first rank, take away the second one. So we have minus 2.5, 1.5, 0. This one's minus 1.5. This one is quite a big difference with 6.5. 1 minus 4.5, 3, and minus 3.5. Now, if you have a think about what would happen if we just added all these together, if you come up with a fairly sensible answer and realise why we then have to square them. So if we square all of those numbers, then we end up with these following scores. So this is our difference squared. Bear with me while I just write these out. And then you should be looking at the formula now and thinking, well, you should see where this is going, because what we're going to have to do is we're now going to have to find out the sum of d squared, and that sigma represents sum. And if we add all of these d squareds up, we get 95.5, which just leaves us working out the correlation coefficient, which is 1 minus 6 times the sum of d squared, which is 95.5, all over the number of bits of data times the number of bits of data squared minus 1. And if you plug that together, make sure if you do it on the calculator, put brackets around the appropriate bits, and that gives us a score of 0.20416 recurring, which basically indicates there is a fairly weak positive